right, so we are going to take a look at another example with the chain rule. And what we're going to be getting into now is going to be slightly more complicated examples that are going to involve kind of rules within rules. You look at 3-part C, you kind of had a chain rule within a chain rule, for example. So when you look at number 5, hopefully you're like, okay, I have inside functions and outer powers, and so I'm thinking chain rule, but I'm also seeing a quotient, so I'm thinking quotient rule. And so the first thing you have to kind of think for yourself is kind of really what is the outermost structure that you're working under. So as you think about this function, what I want you to be thinking of is that in its outermost structure, you have a function of x divided by a function of x. So this represents what I'm just going to refer to again as that outer structure. If that is the outermost structure, then that means that I need to work under quotient rule as my outer structure for taking the derivative. So quotient rule is going to be our outer structure for taking the derivative. So you're not going to write this out, of course, but that's what you have to think about initially. What is the outermost rule I'm working under? If you just jump in too quickly and go, oh, this is chain rule section, so 4x squared plus 5 to the third times 2x divided by 3 squared times 6x squared, then you're going to be missing a lot along the way here. All right, so let's kind of jump in with this. Now that we've recognized our outermost structure is going to be the quotient rule. So our quotient rule is, of course, big old quotient here. And when I first taught it to you, I said, let's just start in the denominator by rewriting that original denominator, quantity squared. And I always said that that was kind of my prompt, that I start with that denominator left alone. So just the regular denominator is what I start off my first factor in my numerator. And then times. Now, I'm looking at the numerator, x squared plus 5 to the 4th. This is a chain rule situation. We have an inside function, x squared plus 5, being raised to that outer power. So the 4th power is the outermost function there. So this derivative is going to be, by chain rule, for inside function left alone, so x squared plus 5, and then that to the 3rd power, times the derivative of the inside, so times that 2x. So this represents the derivative of your numerator, using, of course, the required use of chain rule here. Okay, now we change that order and we say, okay, we'll just leave the numerator alone and then times the derivative of the denominator. Well, once again, the denominator is an inside function being raised to an outer power. So the derivative of the denominator also requires chain rule. So by chain rule, it's going to be 3, that inside function left alone, to the 2nd power. So the inside function just left alone at that stage. And then times the derivative of the inside. So the derivative of 2x cubed minus 1 is 6x squared. So that entire thing represents the derivative of the denominator. Okay, so if you're getting here, you're doing well. I mean, this is the first really sort of complicated, I would say, chain rule that we've had, sort of mixed up with other rules, in this case the quotient rule. So first thing I want us to do is just clean it up. I would not call this simplifying in any way. Maybe it's just, I'm working on the homework, I have to enter an answer, it didn't say I need to simplify, and so it'll take an equivalent form. So I'm just going to clean it up enough that it's going to make it a little bit easier in terms of entering in my answer. So what would make it easier? Well, how about if we write the monomials, multiply those together, and just put those at the beginning of each of these terms. And so we can do that and then just divide by, in our denominator, powers to powers, we multiply, so that's to the 6th. So all I did, 4 times 2x was 8x as the monomial in front of the first term, and the 3 times the 6x squared is the 18x squared in the monomial in the front of the second term. All right, now what? Okay, first of all, do not just jump in and think that you can reduce a 2x cubed minus 1 with the numerator and denominator, because you have subtracting, right? So you can't just like reduce those two. However, if you happen to notice, well, wait a second here, while I can't just reduce those two, I was tempted because I have one here and I have that here. If I also notice, wait, I have that same binomial in the second term, this is going to mean I'm going to be able to factor it out and then I'll be able to reduce it. So that's a good prompt here. Now, as long as we're in the business of factoring things out, and in general, this is how a lot of our simplifying is going to go. We're going to look for things that are common, whether you're doing a quotient rule or with product rules as well. A lot of our simplifying is going to involve getting it into a nice factored form. So I have x squareds plus 5s binomials in both terms. And I also have something definitely that I can look into factoring out in terms of these coefficients here. I mean, I definitely have, something in terms of this 8x and the 18x squared. There's something I can make a go of there as well. All right, so let's do that work. Let's go ahead and factor out some GCFs in the numerator. So from the 8 and the 18, I can factor out a 4. No, I can factor out a 2. Sorry, I can factor out a 2. And from x and x squared, we can bring out an x. With the 2x cubed minus 1 binomials, I only have a squared in the second term, so that's all I can pull out. With the x squared plus 5 binomials, it's only to the third in the first term, so that's all I can factor out. Now, when I do that, what do I have left? In the first term, 4 gets me back to the monomial of 8x, and then one of the 2x cubed minus 1 binomials. The entire x squared plus 5 to the 5th is factored out. Minus, in my second term, I need a 9x to get back to the 18x squared in the monomial. The entire 2x cubed minus 1 squared is factored out, but I do still have one of the x squared plus 5 binomials left. And this, of course, is all over my 2x cubed minus 1 squared. All right, so the whole reason, well, not the whole reason, but one of the main motivating reasons that we did this was to be able to reduce a 2x cubed minus 1 squared with the 6th power in the denominator, and that will now be to the 4th power. And so at this point, about the only simplifying that we have left to really do is going to be really just cleaning up what's left inside those outer bracket, that larger bracketed quantity, which really I just had brackets for emphasis. We can go back to parentheses here. So if I distribute through the 4, 8x cubed minus 4. If I distribute through the 9x minus 9x cubed minus 45 x, looks like there. And so, of course, this is now all over the binomial to the 4th. And so that looks about as good as we're going to get it. 2x, x squared plus 5 to the 3rd. And then maybe the only other thing, if I wanted to, I could factor out a negative from all three of those terms, but I'll just leave it. This is going to be a negative x cubed, a minus 45x, and a minus 4. If we wanted to, we could factor a negative out in front of that whole thing and stick it in front of the 2x, and then all those minuses would change to pluses. Might look a little better, but it doesn't matter. So this would be a simplified form. And so, and I know you're probably thinking, am I going to have to do all that? Not tomorrow, but you are going to have to do some simplifying in here, so the more you start to see now, the better. All right, so I think I'll just make this a short video because next time we're going to come back and look at a new derivative rule.